4, we're going to take a look at elimination. But first, we're going to recall substitution. So we're going to solve the following linear system using substitution. Okay. So we have 5x plus 2y equals negative 11 and 3x plus 2y equals negative 9. We can easily see that the x and the y, both of these in either equation, do not have a 1 or a negative 1 in front of it. Okay, the other thing that I want you to know is that if we were to isolate for the x and bring the y over, we would divide 11 and 2 by 5. We would divide everything by that 5. That will get ugly, okay? And if we decide to leave the 2 on the left-hand side and bring over that 5x, again, we're going to divide negative 11 and negative 5 by 2, again, getting really ugly. So there's certain situations where we are going to find it easier to use elimination rather than substitution. So let's continue this question using substitution, and let's see how ugly that this can get. Okay, so let's just go ahead and isolate for this x in the second equation. The reason I isolated it for this x is because at least the 9 divides by that 3. Okay, so we have 3x, divide everything by 3. We have x equals negative 3 minus 2 over 3y. Okay, very ugly. But let's go ahead and take that x and sub it into the first equation. We have 5x, which is negative 3 minus 2 over 3y, plus 2y equals negative 11. Distribute in that 5, we get negative 15 minus 10 over 3y, plus 2y equals negative 11. This negative 15 can come to the other side, and we would add it. So on the right-hand side, we're going to be left with 4. Now on the left-hand side, negative 10 over 3y plus, we would multiply that 2 by 3 over 3 if you wanted to deal with those fractions. Okay, 6 over 3y. So I get negative 4 over 3y equals 4. And then at this point, we can cross multiply. 3 up, negative 4 down. Okay, we get 12 over negative 4, which is just negative 3. Okay, all of the work right here that we did, it's just computational work, but it's quite ugly and it's a lot of work for just half of the question. Okay, let's take that y, sub it back in. We already isolated for the x, so we might as well sub it back into this equation. Okay, negative 3. Those 3's cancel, but don't forget that negative 1. Okay, so we get x equals negative 3, and then negative 2 times negative 1 is now plus 2. Okay, we get x equals negative 1. So finally, the point of intersection, very, very ugly using substitution, is negative 1 comma negative 3. In the next video, what we're going to do is we are going to take a look at the exact same 2 equations, but next time using elimination, you're going to see how much easier it is and how to recognize whether or not you can use elimination. And we learned in grade 9 that we can do so by graphing. Okay, sometimes this is tedious. Okay, I would rather just solve it with a pen and a paper than to get out my ruler and graph everything. Also, sometimes this is inaccurate if you're dealing with decimals or fractions. Okay, we can solve by substitution. But what we learned in the recall is that sometimes that substitution can involve fractions and it can get really ugly. And I felt like in the recall, it was very, very long. I mean, I flew through it, but for like a student to do that, it's very tedious, very long. Okay, so what we're going to learn now is to solve by elimination. Okay, we're going to look at the exact same. If you skip down here to example 1, we're going to look at the exact same example, but we're going to apply steps for elimination there. Okay, so step 1, what we want to do is we want to get both equations into like the same form. A lot of times we put them in the form where the x term is first and then the plus or the minus, and then the y term, and then the equal sign, and then the constant. Okay, you can do it x, y, constant, and then equals 0, as long as they're both in the same order. Okay. So let's take a look at example 1. We have the x the y, then the equal sign, and the constant on the other side. So we have that for both of these. So step 1 is good to go. Okay, we just have to make sure again that they're both in the same order. Now let's determine how to get rid of one of the variables. So one of the variables has to be the same. Okay, they have to be the same, but they can be like a positive or a negative one another. So we have 2y and 2y, and in this case, they're both positive, okay? So in order to get those down to 0, to subtract those from one another, we are going to have to subtract the two equations. And we practiced this in 1.3 when we created equivalent linear systems. Okay, so let's go ahead and go 5x minus 3x, we get 2x. 2y minus 2y, we get 0. So that's perfect. This is actually right here what we're looking for. Okay, and then we have negative 11 minus negative 9, I get negative 2. So really, if we want to rewrite this, we just simply have 2x equals negative 2, and we can divide out, we get x equals negative 1. Which is exactly what we're looking for. Now we just so that was very, very quick. We recognized that the y's were the same, so we just thought of a way to get rid of them. Now, let's sub that negative 1 back into the original. And you can sub it into either one of the originals, it doesn't matter. Okay, so this is negative 5. When it comes over, we add it. We get 2y equals, and then what's negative 11 plus 5? And 6. And then we get y equals 3. So I get the point of intersection for this is negative 1, 3. And if you look up to the recall, the point of intersection should be negative 1, 3. Sorry, that's negative 3. That negative 6 has the negative on it. There we go. Negative 1, negative 3. Okay. Elimination for an equation that you would have otherwise gotten a lot of fractions for is very, very convenient. Let's just practice. So let's solve the following linear system using elimination. Okay, so let's make sure that everything is in order. We have the x's stacked, the y stacked, the equal signs, and then the constants. So we're good to go. Okay, little difference between this one and the first one that we did is we have 2y and 2y, but the difference is one of these is positive 2y, the other one's the negative 2y. In this case, what we want to do is we can't subtract these. If we subtracted them, they would equal positive 4y. So what we have to do is we have to actually add these two equations, which in my opinion is easier. So we have 3x plus 5x, we have 8 x's. 2 plus negative 2, those just cancel out. Okay, and then 19 plus 5, I get 24. Okay, isolate, x equals 3. So pretty much 2 steps, and we already have x equals 3. Now we have to take that x and sub it into one of the originals. Let's go 3 times 3 plus 2y equals 19. And now we just have to actually isolate for the y. Okay, so 19 minus 9, I get 2y equals 10. And I get y equals 5. Okay, so for this one, we used elimination, and the point of intersection is 3, 5. Now let's solve this one using elimination. Okay, so we have the x's stacked, the y's stacked, and then we have the equal sign and then the constants. So all of these both are in the same order, so that's good. Okay, this one's a little bit different. 10x and 8x are not the same. 4y, 2y are not the same. And then the constants don't matter. We're just pretty much looking for the same x to the y. So we're kind of stuck. So with elimination, what we can do is we can multiply the second equation by a constant in order to get one of these to look like either the 10, the 4, or the 1. The easiest thing to do is to multiply the second equation by 2. So we're going to have 16x minus 4y equals 14. Now we're dealing with this equation and equation number 1. Let's just write that underneath. 10x plus 4y equals negative 1. We'll chunk that up. Okay, now the y's are the same. So let's add the two equations because we have negative 4y and then positive 4y. So by adding the two equations, the y's are going to cancel out. So we get 26x, those cancel out, and then 14 plus negative 1 is 13. Okay, divide both sides by 26, and we get 1/2. Okay. Still a little bit ugly because we're still dealing with a fraction, but this time we were able to do this in, again, like 2 or 3 steps. Find an equivalent equation by multiplying the entire equation by 2, and then just adding. So now let's substitute the x equals 1/2 back into either one of the originals. Okay, so let's go 10 1/2 plus 4y equals negative 1. So this is just 5, and let's bring it over. We have 4y equals negative 1 minus 5, which is negative 6. Okay, divide both sides by 4. I get y equals negative 6 over 4, which is just y equals negative 3 over 2. Okay, so therefore the point of intersection of this one is 1/2, comma, negative 3 over 2. So let's solve this one using elimination. Okay, so let's check that the variables are stacked. So the x's are on top of one another in the same order as the y's, the equal signs, and the constants. Okay, great. Now, 4, 5, 3, 4. Here's the issue. The x's are not the same, and the y's are not the same. And then the other issue is that the x's aren't multiples of one another. In example 4, we only had to multiply one of these equations by a constant in order to get the y's as the same term. In this situation, we actually have to multiply both of these equations by a constant in order to get either the x's alike or the y's alike. I'm going to show you the easiest way to do this. See this 4x and see this 5x? We're going to multiply the first equation by 5 and the second equation by 4, and therefore both of them are going to have 20x as the front number, as the leading number. Okay, so 5 expanded in here. 20x plus 15y equals 13 times 5. 65. And we're going to have 20x minus 16y equals, and then 4 times 7 is 28, so negative 28. Okay, so we're going to multiply, again, going back, we had to multiply both the first and the second equation by a constant, and you kind of just flip those two leading coefficients in order to get the 20 and the 20x gone. Okay, since 20x and 20x are identical, we're going to subtract the two equations. Okay, so those cancel, the x's cancel. 15 minus negative 16, I get 31y. And then we have 65 minus negative 28, I get 93. Okay, divide both sides by 31, and I get y equals 3. So not bad, very, very clear. Okay, let's sub that back into, let's just do the first equation. Both of them are quite ugly. Okay, so we have 4x, this is 9, and we bring it over. So it's 13 minus 9, which is just 4. And then when we divide by 4, we have x equals 1. So therefore, the point of intersection of this linear system is 1, 3. We're going to do the same thing, solve using elimination, but then the additional part is we're going to check. Okay, we're going to check that our point of intersection is correct. Okay, so let's take a look. These are stacked. The x's, the y's, and the constants are stacked. So we're good to go. Okay, we're going to start. 3 and 4 are not multiples of one another, and neither are 2 and 5. So let's just use, actually, let's use the 2 and the 5 this time, just so we mix it up a little bit. Okay, so we're going to multiply the first equation by 5 and the second equation by 2. So we'll have 15x plus 10y equals 10. And we're going to have 8x plus 10y equals 24. Okay, in this one, the y's are identical, so we're going to subtract the two equations, and those are going to cancel out. Okay, 15 minus 8 is 7, so we have 7x, and then 10 minus 24 is negative 14, and when we divide that out, we get x equals negative 2. Okay, sub that into the first equation, 3, negative 2 plus 2y equals 2. This is just negative 6, and we bring it over. 2y equals 2 plus 6. 2y equals 6, 7, 8. 8. Y equals 4. Therefore, the point of intersection is negative 2, comma 4. Okay, I'm going to erase this page, but we're going to check that negative 2, comma 4 is indeed the point of intersection. Okay, so we're going to do a left side, right side check, but for both of these equations. Okay, the point of intersection has to satisfy both of the equations, so we can't just sub in negative 2, comma 4 into one of the equations. We have to do it for both. Okay, so we have 3x plus 2y equals 2. Okay, if you remember the left side, right side check, left side, right side. Okay, so 3, negative 2 plus 2, 4, and that should equal 2. Negative 6 plus 8 should equal 2, and yes, it does. So the point negative 2, comma 4 does indeed lie on the first line, so that's good. Now we have to check the second line. So 4x plus 5y equals 12. Okay, left side, right side. When we talk about left side, right side, we talk about the left side of the equal sign and then the right side of the equal sign. So let's sub in negative 2 and 4. And we have negative 8 plus 20. And does that equal 12? Yes, it does. So the point negative 2, comma 4 lies on that second equation as well. So this point of intersection is definitely the point of intersection. It satisfies both equations, okay? And or we can say that both equations have this line in, or this point, sorry, in common. It's a word problem. So let's read this together. A small store sells used CDs and DVDs, okay? The CDs sell for $9 each. So CD is $9 each. And the DVDs sell for $11 each. Cody is working part-time and sells a total of $204 worth of CDs and DVDs. And he knows that he sold 20 items. Okay, so let's start with two different variables. Okay, we need to find out how many CDs did he sell and how many DVDs did he sell. So X and Y are actually going to pertain to these two things. Okay, number of CDs sold, and then also the number of DVDs sold. Okay. Right here, we know that we sold 20 items altogether, so simply X plus Y is going to have to add up to 20. Number of CDs and the number of DVDs equals 20. Okay, in the second equation, so the first equation, I think about like the theme, and this is like the number sold. That's what this first equation is about. Now the second equation is going to all be about money. So CDs are $9. So he's going to make $9 times the number of CDs that he sells. and $11 times the number of DVDs that he sells, and this is going to add up to $204. Okay, so because we're under the elimination part of this unit, let's actually go ahead and use elimination to solve for this. Okay, so we can make multiples of 1 to equal 2. So let's multiply 1 by 9. And then the x's will be the same. So we're going to have 9x plus 9y equals 180. And then we still have 9x plus 11y equals 204. Okay, the 9's are going to cancel out if we subtract the equations. So 9y minus 11y, I get negative 2y. And 180 minus 204, I get 24. Okay, so I get y equals, that's negative 24. So we're going to get y equals positive 12. There we go. That's better. Okay, so in total, we sold, or Cody sold 12 DVDs. Okay, then simply x plus y equals 20. So if we know that he sold 12 DVDs, we know that he sold 8 CDs. And we can say, therefore, Cody sold 12 DVDs and 8 CDs. And if ever on a test or an assignment you want to check if this is correct, all you want to do is sub it into both equations, 8, 12.